Hello and welcome to Matillion's virtual series, Leading the Data Transformation. During this series, you'll hear from Matillion, Snowflake, and our partners and customers on how modern enterprises are driving real business value from data and cloud strategy. You'll learn how your peers select and implement a cloud data platform, the methods used by innovative and often remote data teams to get their first quick wins, and much, much more. No matter where you are on your cloud data journey, you'll leave each session with a list of actions to take back and use with your team immediately. In this session, you'll listen in as Robin Meehan, CTO at Inawisdom, and Ian Fennell, Director of Solution Architecture at Matillion, discuss some of the most common, yet most challenging questions data leaders ask every day. You'll learn their top tips for overcoming internal stakeholder misconceptions about cloud data migration, and how to prove the ROI of everything from descriptive to predictive analytics. Thank you for joining us.
Welcome everybody to today's webinar. Thank you so much for joining us. We're going to be talking about demystifying cloud data, data transformation in the cloud, co-presented by myself, Ian Fennell, Director of Solution Architecture at Matillion, and Robin Meehan, founder and CTO of Inawisdom. We also have Tabitha, who will be joining us as a moderator from Inawisdom as well. So first of all, to look at the agenda, we're going to split this roughly into two parts, a little talk about Matillion and an introduction of how that fits into the problem domain, a practical demonstration of Matillion, at which point I'll hand over to Robin to bring to life in some more depth the concepts around AI and ML. So first things first, let's talk about Matillion and how you get value out of your data. So the tool stack that Robin and I are going to talk about today is a great part of achieving that. We're going to be focusing on AI and ML, and of course, how you get your data into shape in the first place to begin with. With regards to where Matillion fits into this, Matillion is a cloud native data transformation product. There are actually several products in the range. The one I'm going to show you today is Matillion ETL for Amazon Redshift. We also have Matillion ETL for Snowflake and for BigQuery and for Azure Synapse Analytics, and also very soon Matillion ETL for Databricks. So we try to focus on four main aspects when trying to explain where Matillion fits in. Simplicity in use of the interface, and I'll be demonstrating that when we come to actually look at the products in a few minutes' time. Speed of using the product, and I'll show you some of the tricks that you typically use when you are developing using Matillion. Scalability comes from the fact that all of this is deployed into the cloud, and therefore we take scalability largely from the underlying MPP databases. And of course, the whole thing is based upon a cloud-centric pricing model, hence the savings there. So why are we talking about data manipulation and AI and ML? Well, it's all about, of course, enabling faster, better business decisions based on evidence rather than just hunches. So there's actually a lot of similarity across all of the verticals here that you can see. Many of the problems are very similar in all of these different domains, and we would use similar techniques to address those problems. And that applies equally as well to data transformation and integration, and to the data science domain as well. I'll leave Robin to talk a bit more about why the poor guy there is pushing the data science thing up the hill there. So what kinds of problems are we talking about? Well, they tend to be broadly fitting into the four categories that you can see here. First of all, the source data that you need to get hold of in order to make those decisions is typically siloed and just spread around in lots of different places, difficult to get hold of, difficult to consolidate, and that can be a limiting factor. So one of the ways we try to address that is put that all into one place. Variety of data, well, that's ever growing with especially with new semi-structured formats coming along, and problems with quality and consistency. And the way to address that is to take all of that siloed data, transform it in different ways, such that representatives are consistent. Temperatures are always in degrees centigrade instead of being mixed between centigrade and Fahrenheit, for example. Distances are measured in kilometers rather than in a mixture of units, that kind of thing. And then you can integrate that data together, and you have a good baseline for producing some intelligent analytics off of that. Volume of data, of course, becoming more and more of a problem. Simply getting the raw power to process all of the data which is available. And of course, the great solution to this is to deploy cloud functions and cloud services for processing that data, as well as for storing it as it might be in your data lake. And it's in this way that you get access to basically infinite scalability. Simply the difficulties of getting the processing done that you need on that data. Well, traditionally, IT was very much a bottleneck in that kind of thing. So we're seeing now tools which enable self-service. So tools which abstract away a lot of the complexity, remove need for hand coding where it's not necessary, and simplify the kind of tasks that really should be simplified. So we call that data democratization. Okay, so the Matillion angle on here, I'm going to expend a few minutes to talk about specifically the way Matillion works. I'm focusing on the left-hand side of the architecture diagram here. Robin, in a moment, will talk about more the things which are on the right-hand side. So what we've tried to represent is all of those things on the previous slides. The way that you've got data siloed over here in lots of different sources. It gets extracted from wherever it is, loaded into the cloud environment, which is a cloud data warehouse and or data lake. The data there gets transformed and integrated in such a way to make the definitions consistent, to put all your data on one subject in one place, and then it becomes available to you can at that point, of course, get descriptive statistics on that data, and I'm going to be showing you something like that in a few minutes' time. But that data is the base then for doing inferential statistics, machine learning and artificial intelligence, which Robin will talk about. So at this point, I am going to switch over now and begin the demonstration. Okay, so what I've got on the screen at the moment is my example instance of Matillion ETL for Redshift. And I'm going to show you very briefly some techniques to get your data ready for preparing it for AI and ML. We often at Matillion talk about the scalability angle when we're talking about the kind of problems that we solve. But here I'm going to more focus on the variety angle. So I have in this case a sample data set which came from a PDF file. It's quite an unusual source format for data, but which nevertheless has got some valuable data that I want, and I really don't want to type it all out by hand or do some photocopying and try to do OCR on it, those kind of things. Instead, I want to use the power of the cloud and some software libraries to just simplify that for me. So on the screen, I'm going to show you two main things here. First of all, this is the Matillion ETL for Redshift interface. This is what it looks like when you're using or developing or running software using Matillion. And there are two jobs that I'm going to show you. This blue colored one is what we call an orchestration job, and it controls, basically does the extracting and loading and the command and control aspects of the whole thing. It takes the data from the source, loads it into the Cloud Data Warehouse, Redshift in this case. In a minute, I'll show you the other side of this, which is the data transformation side, which is taking that raw data and just shaping it into getting it ready for use. I will be showing some descriptive statistics in there as well. So and you'll notice as well, by the way, this is all happening inside a web browser. Because this is cloud native, there's nothing to install locally. I'm accessing Matillion through just my web browser. So the extracting and loading part of this, I have completely kind of outsourced almost and run off in a separate server because I'm processing a PDF file, which is slightly unusual, a variety of input data. What I've done is I'm using a library, which is a kind of off-the-shelf library for this. It's called Tabular, and it can parse out basically a table out of a PDF file. So what I have here is a bit of scripting, which is just generic scripting, enough to invoke the library and save the result into a CSV file. So it's this, which is taking the source PDF and converting it into a CSV, which is a much more accessible format and which is directly compatible with the target CDW here. So having done that and just moved that problem onto another server, the data then comes back. It's available in a CSV, and I just have a couple of components here. One to simply create a empty table ready to receive the data, and this component here, which I've built, which is an S3 load component, which takes that data from that CSV file and loads it into the table that I just created. And one thing I wanted to show you here, I mentioned that one of the good things that these kinds of tools do is remove the need for hard coding and for scripting wherever possible. What I've done is basically filled in all of the properties in the UI here and use drop downs where possible. But really, at runtime, it generates this frankly scary looking piece of SQL. But that is all done off, it's all managed for you. So it's in this way that we get the simplicity, the accessibility of a nice user interface and the scalability of the underlying CDW. So a quick demonstration there of just a way to get slightly unusually formatted data into your CDW. So at this point, we have solved the extraction and load problem. I want to now move on to talk about the transformation side of things. And to do that, I'm going to open this job. Let's make that a little bit smaller, and I'll revalidate this just to make sure everything is working okay here. Now, what I have here is a mostly transformation work, a little bit of data integration, which I'll talk about in a moment. And it is all done using SQL. So this doesn't look like SQL at all. another example here of the way that Matillion makes this accessible to not just to hand coders. It makes it accessible to anybody who just wants to work with their data. I'm going to start with this component here, which is, as you can probably guess, the component is the data I ended up with at the end of that previous job. And this is just the raw data from the taken from that source PDF document. And this is a discussion of some English GCSE results, which are school exam results. And it's you can see this is useful for doing a visual check against the source system to just make sure it's been converted across okay. There's a lot of data here. It's in this crosstab format, which is fine, but it's not so easy to use. So I'm going to show you the kinds of things that you can do with this. I'll start off with this transpose operation, which is taken from just one of the menu of transformation components that you have at your disposal. And this one takes it basically converts that crosstab into something that's easier to consume for a CDW. And it's probably easiest to show you the output that generates. Remember, we had grade 1, grade 2, grade 3, grade 4 across the top. Here it's been transposed down, and we've just got an extra level column, and we've got a number which corresponds to the number that was in that cell. Simpler to actually do than to explain. But this is what I'm doing here is illustrating the kind of thing that you would do when you are developing with Matillion. I'm making heavy use of the sample tab here, which is one of the things which gives you speed during your development. If you want to quickly check, did that transformation do what I think it should have done? You can quickly check using this using the sample tab at any point along the way here. So here, what I'm going to do is split these things into two. I want to get some descriptive statistics out of this data set. I want to know which subjects are the most likely, if you choose them, you're most likely to get a distinction, one of the top 3 grades. And also I'm interested to know which subjects are you're least likely to fail at. It's a bit late for me to change my choices, but it's an example of a statistic that you can find just from this raw data. So we have here a mapping component where you can put in some logic, and these are the kind of things that you would create as business rules. If your level is bigger than 7, so that gives you 7, 8, 9, we're calling that a distinction. Otherwise, you get a merit for those middle grades. Otherwise, you can get a pass with a grade 2 or a grade 3. And again, if we show the data sample that results out of here, things with a 0, well, that's counted as a fail. This is coming out in a nicely sorted way. Then we get some passes, some merits, and then some distinctions down at the end here. I then want to aggregate that data up to see how many by band, and here I've told it that I want to group this up by subject and banding, and the resulting data is a bit more aggregated. Looks like this. So there's now a sum at each level. I've also got on this level, on this branch here, a much a higher level of aggregation. It's by subject, and again I can do a little data sample here, and I can see the total number of people that chose that subject, and there's only 20 rows in here. Now, a little example of the kind of thing that you would do with data integration. I've really got 2 data sets here at slightly different granularities, and I want to join them together, which will enable me to get to find out the percentages within each band. So this one, simply joining on the common subject, and the data looks like this. So I can see now that 107 people took biology in total, for example, and there was only one failure. So we've got that data side by side. Now it's easy to manipulate. I can start to put in some percentages. And this is, it's a bit of a mouthful, this, this expression, but it's basically a percentage expression rounded to 2 decimal places. And as always, we can do a little spot check here to see how that's coming out. This is a good example. 27 took this subject. There were no failures at all there, so that's a 0% failure. That's an easy one to spot check. The last thing I'll show you here is just to give you some ideas of the power that's at your disposal in the descriptive world. I was interested in finding out, in ranking those basically, to find out which subjects you're most likely to get a distinction. And here we are using the function, a row number function, ordering by the percentage in the band. And if I look at a data sample, that will hopefully become very clear. All of the results should appear in order here. And the most likely to get a, they're coming out in the wrong order here. Where's my banding? Digital photography, I think this is the one. Actually, I need to filter here, don't I? Only on the banding that I want. Here we go, this is it. So the computer science, 27 people took that. A full 25%-ish, 26% got a distinction. So that's a good choice if you're looking for a distinction. Similarly, kind of the other way around, if you're looking to not to fail a subject, then these are the subjects to choose. Digital photography is up there. No failures at all. No failures at all in physics. I always thought physics was tough, but there you go. The data's not lying here. And biology in third place there. And I will show you finally on here the SQL statement behind this. As I mentioned at the beginning, this is all SQL. And this is what the thing is really doing behind the scenes here. Quite a chunky piece of SQL. And if you were trying to hand code that, well, you probably could, but it would take you all day. And you'd have a job on your hands there to maintain that. Little recap. On the Matillion side, I've been talking about how you acquire, how you extract and load data, and how you can then transform that and get some descriptive statistics out of that. In a moment, I'm going to hand over to Robin, who will now talk about the next steps, what you can do with that transformed and integrated data in the world of AI and ML.
Okay, thanks, Ian. Thanks for going through that, and I'll build on what Ian's just covered, and then, as he said, dig into the AI ML side of that and how we use Matillion in the field, really. So that's my topics for the next few minutes. I'll also go through some of the pitfalls and challenges at the end as well that we see with that process. So just introducing Inawisdom very briefly. So we're an all-in Amazon Web Services premier consulting partner. So we work in the space of AI and machine learning. So really what we're about is around helping our customers to leverage and get value from their data they hold, and also data combined with other private or public data sets. So that's the area we work in day in, day out. And so we use Matillion as part of that process for some of our customer projects. And I'll bring that out as we go through. So first, just to do a bit of a scene set around kind of what is AI and ML, and then maybe some kind of why would I care. So in terms of what, so this is just a quick screenshot from one of our education packs that we deliver for customers. So it's a common question we get is to do some kind of orientation education sessions around AI and ML. And as you can see from the table of contents, so the key takeaway here is it's a very broad church. So so there's the kind of the whole debate about what is AI and what is machine learning, which I won't delve into now. And then in the ML broad church, there's supervised, unsupervised, reinforcement learning, NLP, so natural language processing, which is a kind of a defined subset, and people are generally kind of skilled, have that as a deep specialism. Deep learning is another whole topic to cover, so getting into neural network side. and so on. So there's a very wide range of things and topics to cover, and that's one of the challenges, I guess, with ML and machine learning is that we're talking about a very broad discipline with lots of use cases. In terms as to why to use it, I probably don't need to describe that very much. We all see this in our kind of personal as well as our professional lives. And the bottom line for us and why we set up Inawisdom, it's all around, for me, this is the next frontier of differentiation for organizations and value that they can extract from their data. So much of the process optimization sort of advantage from IT has been had over the last 20 years, sort of squeezing out efficiencies through IT. And the next frontier for differentiation between organizations and how they're going to stay competitive is around leveraging their data and combining data sets to get greater value from those assets. So for me, this is exactly where it's at. So just to bring that to life with some examples from us and some other examples from industry and out in the wider world. So just picking top left there, for example. So Aramex is one of our key customers in the Middle East. So they're a shipping and logistics business, a huge organization in the Middle East region. And so for those guys, we've delivered and productionized machine learning workflows, which Matillion is actually part of the architecture for this customer. And to give you an example use case, so their challenge is around, they're doing shipping, thousands and thousands of parcels and packages all the time. And so predicting when those packages will be delivered. So shipping date prediction is really key. So we managed to improve their prediction by 74% in terms of prediction accuracy, which is obviously a great customer satisfaction win, but then also that reduced inbound calls to their contact center. So it gave them an operational advantage by reducing their inbound contact center calls for that topic by 40%. So there's a kind of financial payback as well as a customer service loyalty payback. So that's at the kind of optimization end of the spectrum. If we take the next one, so this is about Formula One. So this is a case study for a partnership that Amazon Web Services have with F1, which is all in the public domain if you Google it. So it's really exciting, interesting things that Amazon and F1 have done together around adding extra, using machine learning models to predict scenarios in race. So sort of second by second on the kind of, with really rapidly changing data. So examples, if you watch F1, you'll see on-screen graphics describing how long is a pit stop likely to be, or will they get out of the pit stop quicker than earlier than will they come out in the track ahead of their opponent, behind their opponent? Or another one is around predicting overtake, probability of an overtake actually mid-race, right in the middle of a race, using machine learning data trained on that particular racetrack and live from that event. So that's a fan experience use case. And picking one more, so say bottom right for Snoop. So this is another one of our customers. So Snoop are a really interesting, innovative fintech startup, and they're for those guys, we've delivered a recommendation engine that provides recommendations to consumers on financial services advice, or kind of what they call Snoops. So recommendations for saving money or getting better deals in the market and those kind of things. And so as well as forecasting, which is mentioned there. So that recommendation engine is a great example of using machine learning to add real value to the kind of consumer experience. And there's loads of other case studies which I won't go through. But the key point here really is it's a very broad, it's a broad church subject, as I said, and so there's a huge range of applicability of machine learning and AI to use cases. So the possibilities are pretty endless, really, and that's kind of a blessing and also a challenge. So just as a quick aside, I just wanted to show something from from a project. This is anonymized from a customer project. And this is around process optimization for a chemical process. So we're trying to maximize the yield from a chemical process. And the reason I wanted to show this was just to sort of get across the complexity of the data that we're handling. So the kind of data we might crunch and process through Matillion jobs. One of the big challenges we have in the data science community, so it's not unique to Inawisdom, is we're handling very high volumes of complex data, and it's multi-dimensional data. So you've got columns and columns and columns. And we also join these complex data sets together. And humans are just really bad at working in a kind of multi-dimensional space, right? It's just not one of our strengths. And so we need tools and techniques to be able to gain intuition as to nature of the data quality issues, distributions in the data sets, what's correlated with what, and all these kind of things. So we go through a phase in our data science project called EDA, Exploratory Data Analysis, and we'll produce visualizations as part of that. So here's an example of one where we want to gain a kind of intuition as to the sort of contour of a multi-dimensional surface. So this is I just wanted to show this because it's a nice kind of visual representation of the kind of outputs we get after we have been through a kind of nice ETL pipeline and process and cleansed and transformed our data, so we can then make it usable for a machine learning model. So what's the machine learning process that we need to support with technologies like Matillion? So here's a quick high-level view of the machine learning process. This is actually from Amazon re:Invent in Las Vegas from a couple of years ago when I was there, and it's just a nice simple representation that brings the point I want to make to life, really. So the bits of the process that we're talking about on today's session is really the three in purple, so data collection, integration, and preparation, and also on the right there in the green, feature engineering. So these are the bits. It's a truism in machine learning circles that maybe 80 or 90% of all the effort is really on the data engineering. That's where the kind of heavy lifting is. The machine learning model building it can be heavy lifting, and is kind of where the magic happens. But the hard graft, if you like, is in those purple boxes and that green box I just referred to. That's where the kind of iteration happens, as well as you improve your models over and over time. So machine learning without good data is a pretty disappointing process. It's really important that we get this right, and as I say, this is where the kind of engineering effort really comes from. So early on in a data science project, when you're doing sort of discovery hypothesis testing work, then typically a data scientist will do these things natively in Python or R. But then when you want to move to a kind of production footing and industrialize it, that's where you need stronger tooling that can handle the other kind of operational considerations that you're interested in. So we need to handle lots of different data sources, exactly as Ian was just starting to cover there. We want to run processes unattended, as in like scheduled processes without humans in the loop. And we want to have good error handling. We want to be able to handle exceptions. We want all those kind of operational controls. So this is why, getting to the point on that, this is why Matillion is a key part of the arsenal and the weaponry that we use for these kind of projects, because we need to ingest from lots of data sources, do lots of complex transformations. We want to develop them quickly, so we want a nice graphical IDE, and that's where Matillion sort of fits into our toolkit. So just to show an example of that, it's a little bit fuzzy. I apologise because it's been anonymised. But here's an example of a real Matillion workflow from a job from a customer project. So just to talk through what we're seeing here. So as I said, you've got, as Ian described, you've got multiple data sources you might want to ingest. Here, what we're then doing in this next phase here, this first collection, we're actually doing a sequence of transforms, but we're running them all in parallel. So one of the powers of this, and this is with Matillion doing sort of push down processing to a AWS Redshift cluster. I think we use something like a 16 node cluster here. We have using the sort of pushing it down to the power of the MPP that is AWS Redshift. We can run all these transformation steps in parallel and then join them all back together. So that speeds up our kind of pipeline latency through the pipeline. Other things we've got going on here is this next collection is a collection of unit tests. So we really care about data quality, meaning bad data in is going to produce inaccurate models, or models that maybe even crash during the model training process. So for example, some machine learning algorithms can't cope with missing data. So we're running a bunch of unit tests here in Matillion, which are running essentially QA data quality checks across our data, and they can stop the ETL process from continuing if our machine learning pipeline is not producing sort of data of sufficient quality in order to carry on with the rest of the pipeline. Other things happening in this pipeline actually is we're also involving Amazon ECS, for those who are familiar with that, and there's other kind of complexities I won't delve into at this point, but you get the idea. So we can build a kind of arbitrarily complex data pipeline. And the ultimate right-hand side of this is to then train and evaluate our machine learning model. So if I map this onto Ian's example from taking the exams and the exam board stuff, let's imagine that instead of just having one PDF, in Ian's example, it's kind of tuned for a webinar, let's imagine that we have data from multiple sources. So we have demographic data about students as well. So we know which students took what, and some demographic data like age or previous education history. We have data from multiple exam boards because the students have taken exams across multiple exam boards as well. We want to ingest those, we want to go through this pipeline. So you can imagine that the kind of complexity of the transformations and joins that we want to do are getting more and more rich. And then also in this pipeline, I didn't mention, but we're also doing our test train split. So so for those who aren't familiar, so in a machine learning context, we'll split the data into 2 or 3 discrete data sets. We'll train on this data set, and then we'll evaluate our model against data it's never seen, so that we can get a true blind test as to the true accuracy of our data on previously unseen data. So again, that's happening in this pipeline. You might question, just a little Matillion thing just to bring out, which I think is really nice, is there's a capability in Matillion to do generate job documentation. That generates an HTML file, which I've just put a quick screenshot there on the right hand side. So that's where we've got this image from. You can document all the job that Ian was showing you earlier, and get support documentation and add notes to it and so on, and get a kind of record of exactly your ETL processes or ELT as they get more and more complex, but you need to support them. So that's a quick run through of where Matillion fits into in our processes when we use it with customers. So I just wanted to now just spend a few moments before I wrap up on where some of the sort of advice or traps or pitfalls are. Now there's a blog post on our website, the URL there, that I wrote some time back around how to set up your own data science capability and the kind of anti-patterns and remedies, which is kind of touching on this area as well. So if you want to read more, there's more in there. But just to quickly whip through some quick points. So the first one is that there's generally in organizations, there's a plethora of opportunities where machine learning could have a business benefit and where to play. And there's kind of vanity projects, and there's very commercially grounded projects, and there's kind of innovation projects that might lead to new revenue streams, for example. So you need a selection process to help you prioritize and weigh up where you're going to start. And also don't do too many in parallel, right? Don't kind of boil the ocean, do 1 or 2 really well and then move on from that success. So takeaway number 1, pick your battles. So, or the anti-pattern, if you like, there is that if you do too much at once, you'll kind of fail across the set, and then you'll lose your impetus and your momentum. The second point to make is it's really key to get and maintain buy-in, especially from your business stakeholders, because machine learning is not well understood, if you like. So it's a complex subject, and it's easy to have a kind of disconnect between your sort of data science community and your business community if you're not careful. So stakeholder and buy-in is really key. Part of the answer to that is to have very small, short, sharp, sort of funded hypothesis tests. So discover business value, or prove it can't be done first. So run short, sharp projects. So discover first, and then scale up and make your bigger investment. So discover first, invest later is another key point. And then kind of related to that, so then it's really key to have a delivery process and a method. So data science there's established methods, as Chris DM, which is mentioned there, which we've taken as our inspiration as well. So key takeaways really hard in this method is, like, as I said, be brutal on the scope and the success criteria that you're aiming for. Be really clear on your CSFs before you start, just like any good project, right? Write a good terms of reference. Have an iterative approach, because this is a discovery process, and so you will get, the number one thing I would say is you will find surprises in the data as you go through your output, say, of your Matillion pipeline, and then run some analytics, descriptive analytics. You'll find surprises in there for sure, and that may change your direction. And really carefully time box what you're doing. So keep it to set a time limit and stick to it, because there's no magic point at which there's a natural end to a science experiment. So you've got to set one, otherwise it will roll forever, and then everybody loses interest and you'll lose funding. So that's one to take care of. So then just to wrap up, I wanted to kind of wrap that all up in a bow and just go through the journey, the life cycle over, say, about an 8 to 10 week period of what it could look like and what it looks like when we work with our customers. So in week 1 there on the left, as I mentioned just a moment ago, the first thing really is to have a really clear prioritized list of business value versus feasibility assessments. We have a method for this to help prioritize where you put your limited your limited investment budget. Then you pick where you're going to invest. Then you move into the discover phase. So deliver a quick proof of concept, so prove the value. So basically do some data ingestion, process that, and build a, if you like, a quick and dirty AI ML model. By quick and dirty, I mean you're not chasing ultimate accuracy here. You're chasing learning. You're biased towards learning the value rather than like the last 2% of accuracy at this stage. And then in stage 3, then you play back your findings and crucially, you produce a business case. So you convert machine learning model accuracy into, if I did this in the business, I could save Y pounds. It might cost me Z pounds to implement and I'll save Y pounds, or I'll retain X extra customers, or I'll have this new line of business that will generate this revenue. So convert it to business metrics is really key, because if there's no impact, you shouldn't be doing it. Okay. Assuming you get buy-in and approval for your business case, then you move to stage 4. So this is where you want to accelerate. So you want to build a minimum viable product, an MVP. So keep it simple, keep it small, as small as you possibly can. Could even be that the output is, if you like, manually keyed into a system at this stage, or perhaps a good example is a prioritized list of which customers to target today because they're the highest likelihood of conversion. So you can do that in a relatively low fidelity way and convert a paper-based business case to real evidence business value. And then as you move through to stage 5, you can productionize that. So start building in the fully automated transformation and modeling process and monitoring with alerting. And this is where Matillion will really come into its own, for as in like the Aramex use cases I described before, and our other projects. This is where you're really now in an engineering space rather than a data science space so much, and that's really key. It's where you're embedded into your organization, into your organization's support processes, and so on. And so that kind of unattended, safe, and well monitored and well looked after kind of data ingestion and pipeline is really key. And then last but not least, then there's kind of after your week 8, week 10, then you've proven some amazing value, you're famous, everybody wants to be your friend, and then you can go around the circle again and enable and do the next use case off the list and just drive stronger and stronger adoption, and essentially help drive your business to be a more data-driven business. Okay, that's all I was going to cover. Thanks for listening.
Okay, thanks Ian and Robin, that was brilliant. As you know, the theme of this webinar is about demystifying cloud data myths. And I think you've both done a great job there in handling a lot of that subject in your presentations. But I just wanted to throw at you a couple of extra sort of common questions that we often get asked by customers around kind of data in the cloud. So I'm going to kick off with, is there such thing as bad data? As in, can all data be sort of extracted and transformed? And then is all data ready for AI and ML services? So if I can throw that to you, Ian, first, and just from your point of view, kind of, is all data able to be sort of extracted, transformed, loaded, or is there some restrictions?
It's an interesting question. It's kind of by definition, if the data is coming from an operational system and it's being used to run a business, then it's good enough. There's an argument along those lines, and probably as Robin was talking about a few minutes before, there is potential value in every data set. You've just got to be careful to choose the one which is going to be most accessible for you to give the most value. So I would say probably pretty much regardless of variety or volume, then yes, there is going to be value in pretty much all data. However, to the second part of that question, is all that data immediately ready for input into AI and ML? Almost certainly not. And I think the pattern that Robin was demonstrating in the real live example there was a fairly good example of a generic approach that you might take. So take that raw data, import it all as is, then do some transformations, some integrations, get it as consistent and ready as you can, and then do those quality checks just as a gate there before you pass on to those algorithms, because they will silently do something strange unless those specific quality criteria are met.
Brilliant, thank you. And Robin, to you, your take on kind of bad data, and is there such a thing?
I think, yeah, so answering sort of two aspects of that. So from a what can you use, is there a bad data from the point of view of, is it hard to access or use? So I think we work across structured data, unstructured, so voice, text, and also highly structured data sources, so sort of database type records, obviously very commonly. So yeah, we can use all of those. I don't see neither that. I suppose to a data scientist, there's no data they can't use. There's just a different amount of difficulty in the feature engineering, right? It's to boil it down. Because even with text data, we ultimately boil it down to numbers, right? With voice or image data, we ultimately boil it down to numbers that we can plumb into a machine learning algorithm at the end of the day. So I don't see any big barriers there. And I would say it's most common that we use data from different classes of data. The real power from this comes from taking different data sources and joining them. So it's not like having all the value in one master mega data set as the crown jewels. It's generally about some value here, but that value is kind of amplified by joining with this, and this, some of which are outside the organization. And that means you're always bringing structured, unstructured and stuff together. The other thing to say on a bad data front is around data quality. So I would say it's absolutely the norm that we have data quality issues on every project, meaning every source data is imperfect. So I suppose even an image, it could be it's a noisy image, like it's not a very well taken photo, for example, or in database records, you might have missing names and addresses, or incorrectly typed postcodes or whatever. So that this is absolute. So I'm not moaning about it. It's the norm, right? It's what makes it kind of interesting and challenging. And absent or missing records, so like occasionally missing fields, is a really common problem. So we have various strategies for dealing with that type of bad data as well. So data cleansing, transformation, those unit test sort of DQ data quality checks that I showed in the example actually. Imputation of missing values is a classic sort of machine learning technique, and there's various strategies for that. And there's another technique called upsampling and downsampling to deal with sort of imbalanced data sets and too much of one thing and not enough of another, to put it crudely. So there's strategies for all these things, and I'd say that if you like, bad data is not a good reason generally for not getting going. There's usually strategies to deal with it.
Fantastic, thank you. Well, it sounds like there's a path forward for most data types and companies, so that's good news. So the next question then is, obviously you've spoken a lot today about ETL strategies and AI and ML. So is there huge complexity in these types of processes? How quickly, for instance, could an organization get started? And Robin, we'll come to you first this time.
Okay, thank you. I think you can get started very quickly for sure. I think that primarily due to cloud computing, the barriers to entry, if you like, for this kind of stuff are massively lower than they were, I don't know, 10, 20 years ago. So, I mean, barriers in terms of the scale of what you can achieve, obviously the kind of internet connectivity and the cost point at which you can achieve it. And so that means you can build your own data pipelines and so on. So it's amazing what could be achieved, frankly. Though I would stress that there's a kind of yin and a yang to this. That does mean that it's possible to get going without much thought about where you're heading, if you like. And so because there's not a large kind of upfront investment to getting going with these kind of data pipelines and then maybe feeding through to an AI/ML process, So that's not it shouldn't be viewed as a kind of substitute for everything I talked about earlier about understanding why you're doing it, what the business value, you know, what's the kind of terms of reference that you're working to, what does success look like before you really started. So that would be my warning, was just because the tool friction has been reduced, don't be seduced into thinking you don't need to think about the why you're doing what you're doing.
Fabulous, thanks. And Ian, now to you.
Yeah, indeed. So I can't add much to what Robin was saying there, but except to say that the tools and the services which are becoming available to you deployed through the cloud, such as Redshift and Matillion, of course, really enable you to get off to a flying start there. And in fact, it's possible. We have a demonstration of an ingestion of 1 billion rows of data into a brand new 16-node Redshift cluster, exactly like Robin was describing there, processing that data and launching a visualization tool and getting some results out of that within 15 minutes. So it is possible to do that really very quickly and very cost effectively. But absolutely echoing Robin's point as well there. Yeah, just you do need to think about what you're doing, because that's obviously you've got to achieve a business result at the end of the day.
Great, thank you so much. Yes, I mean, again, sounds like, you know, complexity that might have existed a few years ago is you know, certainly tempering over time. So a good message, I'm sure, for lots of organizations looking to sort of start a cloud data strategy. So my last question then, and this is, I know, mentioned by Robin earlier, if you could give somebody a tip or just say what would be the kind of key pitfalls or traps to avoid when they're sort of thinking about a cloud data strategy and perhaps how they want to extract kind of the most value from that data, is there a couple of things you'd say that you've learned in your experience to avoid, or sort of traps to think about before they start that? So Ian, can I ask you to start the question?
Yeah, another really good question there. I would say tip number one for me would be agile about what you're doing. Data is a tricky thing to pin down. It always has a tendency to misbehave. So if you try to specify exactly what you're going to do with it to the 10th decimal place up front, you will find when you put real data into the thing that it will misbehave in lots of unexpected ways. So I really think it's a powerful methodology to do something, apply a transformation, check it out, see if it's valuable, and then refine and go iteratively. So the whole approach would be iterative. I think that's just a fundamental thing to bear in mind.
Fantastic. And finally, Robin, same question to you, and specifically around kind of the AI ML side. Any sort of pitfalls or traps you want to make our listeners aware of?
Yeah, I thought I'll answer that with a couple of kind of down in the weeds things, as in just to change this. I've talked about some of the bigger meta things, process things like, you know, planning why you're doing what you're doing, prioritization and so on. So just delve into the weeds of these projects and what our ETL, our data engineers live with day in, day out, right? So I suppose one of them is around, one of the common challenges is around ingesting data from data sources that don't have a very good answer for what's called change data capture, CDC. So Matillion has some capabilities for this out the box, actually. But not all data sources are equal, right? And some of the older data sources are really hard to get incremental changes from. So if you want to ingest like yesterday's transactions or the transactions in the last hour, which is a very well-worn road, this CDC point, but it's the day-to-day life of our data engineers is dealing with how to do that with data sources that are quite hard to work with to know what's changed, dealing with deletes and those kind of things. So it's a detail point, but it's you know, where the engineers spend their time. The other thing I'd just call out, not to be underestimated, is around master data management. So again, when we're joining data from all these different data sources to then feed down into a ML process, because you're joining across systems, those systems almost universally don't have the same definition of customer, product, account, I don't know, cost center hierarchy, whatever it might be, right? So any of those differences that exist in your organization will, that fruit ripens and comes out on the tree that is the data lake that's fed into the machine learning algorithm. So that's something to, you can't boil the ocean there because you can't solve that all in one go, but it's just something to go into with your eyes open as to that the actual ingestion may be quite straightforward. It's the cleansing and transformation because of those master data challenges is where the time can be spent.
Brilliant. Thank you so much. I think we've definitely sort of busted some data myths there. So thank you both for your time.